Hello, my name is Gabriel and welcome to a new episode of Concierge.js. In the last episode we left off with the project in a state where a page could support multiple prompts and data was being sent between the prompts. So now that this is working, we should look a little bit into security and how to make sure that our application is being secured without writing too much code. The security layer can be achieved in multiple ways. One way it is to code into the application all the logic required for users management. Another way is to use a standardized solution such as Keycloak. There are multiple identity and access management providers, but this one is open source. By being open source, we can use their GitHub and we can use an LLM to understand the code, because there might be differences between the documentation and the actual implementation. Also, if we play with different versions of the code of Keycloak, it is easier to ask an LLM to read the implementation of that specific version and see how we can debug or work our way around the issues. Now, Keycloak comes with a great functionality. It supports add-ons. This means that if we want to code something which does not exist already, we can write a Java plugin and it will be loaded into Keycloak. By default, when we will open our website, we will be presented with this ugly and not so ugly login, and we can also add a register button. This screen can be configured using themes, which are a CSS and an HTML file that are being loaded into Keycloak on startup. So we can easily configure this to support the branding of the customer. Then, since Keycloak supports social login, we can easily add buttons like sign in with Google, GitHub, Facebook, so on and so forth. Then comes the user federation. This means that Keycloak can connect to an LDAP provider where the user management is being done at an enterprise level, and Keycloak just pulls information about the users. Thus, it is very easy for our customers to manage their users in the same place and not care about our implementation. If we wouldn't go with a solution such as Keycloak, we will have to implement all this manually into our application, or we would have to ask our user to have duplicated work between the LDAP provider and our solution. How can an administrator add users to Keycloak? It is pretty easy. There is a concept of clients and users. They wouldn't care that much about clients. These are applications. They would care about users. And inside users, there is a form where they can input a name, login details, so on and so forth. And they can assign permissions. This would allow our final users to have access only to some of the pages of our application, thus achieving pretty much the same thing as if we were to code an admin panel inside our project. What is even greater is that Keycloak is certified and the user management part can be decoupled from the application part. On top of this, the user management part is encrypted by default. So this is all and good. If we have Keycloak that manages customers, Keycloak will, after each login, Keycloak will produce a token, like a very long string, which contains information about our customers. However, there is still the problem where this very long string, this token, has to be understood by our application, and a decision has to be made if the user is allowed inside our application or not. We can use Caddy. It is very similar to Nginx and others. The advantage of Caddy is that it supports plugins by default. Nginx supports plugins only in the paid version of it. So what we can do is we can block the access to our application from outside, then put Caddy as the access point towards our application, and inside Caddy decide if the user is logged in or not. When the user is logged in, we use the identifier provided by Keycloak to understand if the user can navigate to the page that it intends to. Otherwise, we redirect him to a home page if he's logged in and has no access, or to the authentication page if he's not logged in. Caddy can be installed in many ways. The way we will use it will be with Docker. Same for Keycloak. And our application will be part of their Docker network. So all three applications are inside a network, but our application, Concierge OS, will not be exposed outside of this network. Now, indeed, if somebody has access to the computer where Concierge OS is running, it is impossible to stop him at that point. It is too late already. That is a physical type of attack, and from there on they also have access to the code, so we should not worry about that much. We should worry about the scenario where the application is up and running and somebody tries to access this application remotely. There should be no way of accessing our application directly. All the attempts should go through Caddy, which should decide if the user has access to the application or not. One of the problems with Caddy is that it has an endpoint which can accept a configuration, so this has to be blocked once the server is up and running. I have cloned the GitHub repository of Caddy, and I have opened a new Visual Studio Code instance of Caddy, where I have asked it to create a configuration for us for a domain called outcustomer.com, which of course does not exist, and it should point to 5173, which is the default port of our front-end application. I have specified that Caddy will be installed via Docker, and that all the other ports of this network should not be accessible. Also, during the conversation with the LLM, we were asked about the names of the application. This is necessary for Caddy to reference containers by name inside the Docker configuration, and we name them frontend and backend. Later, probably we should also add OpenAPI, but that since that is a static file, it can be served by Caddy automatically. Then we opted in for an HTTP to HTTPS redirect and asked it to create the YAML configuration file, and it has. Now, after the configuration file has been created, the LLM came back with some requirements. So, first requirement, it is to add the certificate which will be created by Caddy in our OS. This means that when the Caddy server starts, it generates two certificate files. These certificate files do not exist over the internet in a registry. They exist only in our local network because they have not been purchased from an authority. So it is for us to tell our operating system that we trust these certificate files as being authentic, because there is no other entity that can do this for us. And here we have received from the LLM some commands on how to copy them from the Docker container and how to add them for different operating systems. And then we have to add this entry in our hosts. This is because there is no DNS resolver which says that outcustomer.com should point to this IP address. First, we should go to a website, we should buy a domain, and then either them or another service like Google, for example, or AWS has a specific page where we can tell it that we own this domain and it should point to this IP address. Since all these mechanisms does not exist on our local machine, we have to do this manually. Now, the Docker compose file was generated, but since the LLM had no clue about the application that it should run, it left these services pretty empty. We should add more details to them. In order to add more details, the easiest would be to go back to our normal project, and in Visual Studio Code, it is possible to add folders to a workspace. Till now, we have worked inside a folder. Now we can imagine as thinking a little bit outside the box. We'll go outside of our folder and we create a workspace file, which is created automatically by Visual Studio Code. And inside we can reference folders from other projects. What is interesting is that every one of those folders is being tracked by Git independently. So this is the file that we have created in our other folder, and this allows us to keep things tidy while allowing the LLM to have access across different projects. In the same way that we have pulled Caddy from the internet, we will also pull Keycloak underneath, and we will work on the same Docker Compose YAML file in order to add the other services as needed. So now the Docker Compose YAML is pretty clean and useless. It contains the configuration, but only that configuration. What we should do, we should take this and we should move them to Concierge OS in a new folder, and then tell the LLM to add inside our image the frontend and the backend. Here we will have two options on how to do this. We either include all the files of these projects inside the Docker image that comes next to Caddy, or we can look at backend and frontend as two independent projects which will be built using Docker independently, and they will be referenced here as images. We will go with the second option because this allows us to have a pipeline later down the line, and as soon as we do changes to frontend or backend, we can rebuild these Docker images without having to rebuild the whole project entirely. Let's have a look a little at the Caddyfile.json which was created. The admin disabled property means that all the endpoints supported by Caddy, which allows us to inject configuration into Caddy, are disabled. This is good. This means that in a production environment, nobody can inject new things into our reverse proxy. Then the logging is set to debug, and the output is not a file, but is the console output. This we can play with to have more or less verbose logging. Then we have a module called HTTP inside the namespace called apps, which supports two ports, which listens to two ports, 80 and 443. Then it has two servers inside. One is listening to 443 on this domain, and the other one is listening to 80 on the same domain. The one listening to 80 is not HTTPS, therefore it will make a redirect to the same domain and URI, but with HTTPS. So every time we access without HTTPS on port 80, this route will be activated and triggered, and it will send everything to this server here. Probably there are multiple ways of achieving this. We can handle the redirect as a unit, and then we can have only one management point for the application. If we would find more places where a bit of code is reusable, then we should migrate to that solution, but for now should work fine. Now, by looking at the Docker Compose, the last module that is being run by Caddy is the TLS module, where it generates a certificate automatically internally for our domain. And that's how we get to have that certificate file, which we should put in the operating system. Probably we should add this one also in the browser. Depends a lot on which browser and which OS, but this is something that we will see in the future. Also, after we make it work, probably we should have some sort of pipeline which looks at this configuration every time, and when the certificate is being regenerated, because we rebuild the Docker Compose, we should re-export this certificate to, at OS level. Otherwise, it would be pretty annoying to copy-paste commands all the time. The prompt that we'll be using will be something like, yes, please create 2 Docker files which are building the images, and we gave the name of the images and their versions like this. It can create a tag for us after building. However, there is a little conversation to be had about the versions. The way that we have it right now is wrong. In both in package.json and in pyproject.toml, we have versions greater or equal to something. This is bad because when we rebuild the image, we can reach the situation where we have different versions than the version that we were using during development. And this can come with its own trade-off. Sometimes some bugs can be fixed, but other times regression can be introduced, or there can be incompatibility between the versions. Another point to be discussed is, okay, but if we have the modules locally, why should we re-download them? And that is very true. But the reason why we should re-download them inside a Docker file is because if I work on my Mac OS and you pull on your Windows machine, in some cases you will pull a different version of these libraries that is being built for your operating system. Also, my macOS uses an architecture pretty close to ARM, while your Windows machine might use an x86. So these libraries will not work very well if we go across architectures like this. So it is better to pull again the correct versions for the CPU architecture that runs the image. Also, then we can think about something else. What if these versions don't exist anymore? This can be solved with a different tool in a different way. We can have a proxy tool such as Nexus, for example, that caches in our infrastructure all the packages that are being pulled from the internet for, let's say, Python and TypeScript. Thus, even if the websites that used to exist don't exist anymore, we still have our versions. So for different types of problems, there are different types of solutions, and we should use the correct solution. For now, we will build the images as it is. Thank you very much for watching, and see you in the next episode.